So in this video we're going to go through how computers do mathematics. Specifically we're going to look at binary addition. So how do you add two numbers together? Well, it's not actually a very different system than we use. So let's do 7 and 12 as our numbers that we want to add together. So I'm just going to put 7 in. So hopefully you know that 7 is 1, 1, 1 in binary, because 4 plus 2 plus 1 is 7. And 12 is 1 on the 8, 1 on the floor, and then 0, 0. So, how do you do it? Well, I'm going to put a little box in for the carry, because obviously I'm in Excel and it's very difficult for me to write a little sort of 1 above here. I suppose I could do it above it like you do in maths, or write a little 1 at the bottom. But I'm going to put a little carry row in because it's a lot easier, and then that's going to be my answer there. So that's going to be my carry that carries over, just like in normal maths. So let's have a little look at normal maths for example. So 1, 10, 100. And this is important to explain, not as simple as it sounds. So when you add two numbers together like 9, 10 and 16. Okay, so let's just copy that. So there. So let's do these numbers, 19 and 16. So you should know that you go, oh, 9 plus 6 is 15, so you carry 1. So you put a 5 here and you carry 1. But actually what you're doing, if you look, is you're writing 15. You put the 1 there and you put the 5 there. And that is what you're doing. This is 15. So it's not it is carry 1, but it's carry 1 because you're just writing 15. Okay, so then of course this is now 3 and you get 35. So that's the system we use. We just write the answer, but instead of putting the 1 and the 5 here, you put it in a carry zone. And this is exactly what we do in binary, no different. But it does help if you know your binary numbers. So it might be a good idea to write, before you do any binary math, 0, 1, 2 and 3 out in binary in 2 digits. Because that's what we're going to use here. So 0, let's do this. And this will become your carry, and this is your result. And we'll go through this more as we go, and it will become more obvious. So don't panic if you're really confused right now. So 0 in binary, in 2 bits, is 0, 0. 1 is 0, 1. 2 is 1, 0. And 3 is 1, 1. So you should be able to write that out, especially if you've practiced my video from before, because we did it in 4 bits, so you've got to do it in 2. So before you start any binary maths, write that out. Okay, so the carry becomes the bigger number, the 2 column, and the result becomes the 1 column. So that's 0, 0. Right, so, and then you just got to refer to this each time. So I'm just going to grey this out slightly so we know that that is just the, I know I've coloured all these things in now. But so we do 1 plus 0. 1 plus 0 is 1. So we go to 1, so that's 0 in the carry and 1 in the result. 0 in the carry and 1 in the result. 0 in the carry, 1 in the result, because it's 1. So then we go here, 1 plus 0 plus 0 is 1, so that's 1 in the result and 0 in the carry, because 0, 1 represents 1. Okay, all going quite standard so far. Now we've got 1 plus 1 plus 0. Well, that's 2. Okay, so that's 1 in the carry and 0 in the result. So we put 0 in the result and 1 in the carry. Okay, now again, 1 plus 1 is 2. So we put 0, we write 2. That's binary. 1, 0 is binary. Except like before, if that was 15, you wrote 1, 5. Of course, it's 2, so you write it in binary from denary, but you write it 1, 0. So 0, 0, 1 is 1. So that's 1 with a 0 carry. You cannot bother with a carry if you don't have to write a 0. You cannot bother with the zeros because obviously writing 0 is pointless. And then of course 0 plus 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0, and there's no point writing the carries. So let's just check the answer. 16 plus 2 plus 1 is 19, and 7 plus 12 is 19. So that is how you do simple binary maths. You basically follow this system. It really throws students what to put in these boxes, but actually it's just the common sense every time. I know that seems like a bit rude, but it's not. You just got to think about writing this bit out first. That will really help, and then do it. So let's do it again for 2 different numbers. Let's do 17, and we'll do 80. Really random numbers. So let's 0 these out first of all, because that's quite good to do, because most of them were 0. Right carry, right result if you want. if it helps you. And do spend some time in the exam writing this out. A lot of time I say this to kids, they don't do it in the exam, and at the end of the exam they've got 20 minutes to go. It doesn't take too long. You know, you should be able to write 0, 1, 2 and 3 in binary in computer science. So 80, you should know that that's 1 and 1 there, because 64 and 16 up to 80, and 17 is 1 and 1. Okay, that's actually not very exciting numbers, so I'm going to make this 6 more. I'm going to make that 82, because then we've got a 1 there. And then I'm going to make that 23 actually, because that'll be a much more interesting numbers to do. So there's 23, because otherwise we're just not doing a lot of math and we won't see a lot of this. Yeah, in fact I'm going to make that 83, because that's even more interesting, because it has a triple 1 here. So, right, here we go. So it doesn't matter what numbers, I'm just picking those so we have more options, right? So 23 plus 83. So 1 plus 1 is 2. So that is represented as 1, 0. So 1, 0. 1 plus 1 plus 1 is 3, and that's represented by 1, 1. 1 plus 1 is 0. Is it 2? So that is 1, 0, because 1 plus 1 is 2. 1, 0 is 2. 0 plus 0 plus 1 is 1, so that's represented by 1. You could not bother with a 0 if you really want to write the 0 carry in, but you know, there's no point. 1 plus 1 is 2, so that's 1, 0. Okay, 0 plus 0 plus 1 is 1, 0 plus 1 is 1, and then 0 plus 0 is 0. Okay, so then let's look at that here. So that's 64 plus 32, which is 96, 104, 106, and those two numbers are 106. Now, what happens if we do this? Let's just do a really simple one. Teach you something that this is new. You need to listen to this because it's a common question in the exam. Let's delete this out. So we're doing 128 plus 1. Sorry, 100 and let's do 128 plus 1. Let's do 128 plus 128. Okay, very common issue. It doesn't really matter what numbers you do. But basically we go through doing 0 and 0, no, 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 no. Hold on a second. 1 plus 1 is 2. So we've got 0 carry 1 over here. Now, if this happens, okay, obviously you've got an error here because this is now representing the result. This is called an overflow error. And this is basically mean where the number has overflown the system. Okay, the computer knows that because it has a carry out, so it will know an overflow. It'll know there's been an overflow. And there's been some famous NASA, I think it was in 2003, and maybe even not that long ago, an aircraft blew up 50 seconds after takeoff because there was an overflow error somewhere in some of its circuitry and it didn't realise and it exploded. So it's not just a simple problem that you know everyone has fixed. It does happen and needs careful consideration if your numbers overflow. So basically you have to be careful if you try and add, because think about it, you can't do 256 in 8 bits because obviously the next number would be 256. So that's obviously 1 and all zeros, which is obviously going into it. So there you go, that's how you add the numbers together. And just in case, I'm not going to go through the questions, I'm going to get you to do them and then you can just look at the answers together, because I think I've been through enough examples to show you how to do the binary math, and I want you to really practice on your own. So go through the worksheet and see if you can get it right. Just quickly, if you want to look at, we talked in the other video about 2's complement, where this is worth minus 128. So if this were to be minus 128, that overflow actually helps us because that overflow works. So this is 2's complement. So if I was doing minus 129 and then I was doing adding, let's do a minus 128 plus minus 128. Now think of it this time, 0 plus 0, and that carry overflow has helped us because the overflow has made that answer right. Okay, so think about that, it does work. That overflow actually helps in 2's complement because you need to push that. That would have been 1, 1. Okay, so yeah, that minus 128 in 2's complement is that. And then when you add them together, you end up with that, which is what you get. So actually the overflow helps us with 2's complement. You still got to check that it's happened, but it actually helps get the correct result. And there are other issues with that, but I won't go through them now. But yeah, so 2's complement math works. If we do any other math, let's do minus 12. Let's do minus 64, sorry. So minus 64, and we'll add minus 32, which is that. Okay, that's minus 32 in 2's complement. So then this is the same process again, so this is all zeros. Okay, 0 plus 1 is 1. 1 plus 1 is 2, so that's 0 carry 1. 1 plus 1 is 3, so that's 1 carry 1. Okay, so then we've got minus 128 plus 32, which is what happens when you add those two together. You get minus 96. So you can see that 2's complement does work with binary maths. That's one of the main reasons it's used.